First of all, we will discuss the solution of this question. Look at these circuits. Come to the first one. What is this? This is an iron nail, and iron is a metal. So what do you think? What will happen in this circuit? Yes, electricity will flow in this circuit as metals are good conductors of electricity. Now come to the second one. What is this? This is coal. Coal is a non-metal. So what will happen? Will electricity flow? No, because non-metals are bad conductors of heat and electricity. Now come to this one. This is eraser. Eraser is connected in the circuit and eraser is a non-metal. So will electricity flow? No, electricity will not flow in this circuit. Now come to the fourth one. What is this? Steel spoon. Steel is an alloy consisting of metals. So what do you think? What will happen? Yes, electricity will flow in this circuit as metals are good conductors of heat and electricity. Position of metals and non-metals in the periodic table. Let's study the position of metals and non-metals in the periodic table. You can see that in red color, metals are being displayed. On the left hand side, you can see the two groups of alkalis and alkaline earth metals. Below, there are lanthanides and actinides. These are also metals. Above, you can see the transition metals in between. On the extreme right, you can see in green color, there are non-metals. Hydrogen is also a non-metal, so it is being displayed in green color. In dark blue, there are metalloids. So the position of metals and non-metals in the periodic table is clear to you. Let's proceed. Now you are well acquainted with metals and non-metals. Till now we have discussed the physical properties of metals and non-metals, and now we will discuss the chemical properties. Let's test your previous knowledge. You have learned in class 7 about physical and chemical changes. Do you remember? Can you tell me what are chemical changes? Yes, you are right. Chemical changes are those where new products are formed. The formation of new substances indicate chemical change. Chemical properties of metals and non-metals. You recognize these are wheels, right? Can you see something in background also? Pay attention to the red part. What is this? This is some reddish brown material deposited on wheels. This is rust. You must have seen in your homes things made of iron get rusted. So what is this rust? What is this reddish brown material you have seen? This is rust which is made of iron oxides when iron reacts with oxygen in the presence of water. That means when it reacts with moist air, it forms hydrated oxides. So rust is the mixture of iron oxides or hydrated iron oxides. The reaction can be represented as, here rust is a new substance. So it is a chemical change. The chemical reaction can be represented as follows. As the process of rusting continues, iron eventually loses its strength. Rusting does not occur in dry air. So the presence of water is very necessary for rusting to occur. Take a small amount of rust powder and dissolve this powder in water. Take a dropper. A small amount of solution is taken and dropped on the litmus paper. When the solution is dropped on red litmus paper, it turns blue. What does it indicate? Yes, you already know that bases turn red litmus paper blue and acids turn blue litmus paper red. So oxides, these iron oxides are basic in nature. Let's see another example when metal reacts with oxygen. Take a magnesium ribbon and burn it in air. What will happen? Magnesium oxide is formed, which is a white powder. Now take this white powder, dissolve in water, make a solution, and then take this solution and drop by drop put it on litmus paper, red litmus paper. What will happen? You will observe that litmus paper turns blue. That means red litmus paper is turning blue, indicating that magnesium oxides are also basic in nature. So we can infer that oxides of metals are basic in nature. We have learned the reaction of oxygen with iron and magnesium. Can you answer one question? Have you seen green material deposited on copper vessels? Or why do copper articles turn green? I will explain. Copper is a metal, as magnesium and iron are metals. So when metals are reacting with oxygen, and copper is also a metal, it also reacts with oxygen and also reacts with carbon dioxide present in air. So what happens? Copper reacts with oxygen and carbon dioxide in the presence of water to forms a mixture of copper hydroxide and copper carbonate. It is called basic copper carbonate due to the presence of OH group. You know that the presence of OH group indicates the base. Reactions of non-metals with oxygen. So far we have discussed the reaction of oxygen with metals. Now we will discuss the reaction of non-metals with oxygen. So let's start. So sulfur is a non-metal. How non-metals react with oxygen? Let me explain this experiment given in your textbook. In figure 4.4a, you can see a deflagrating spoon in which sulfur powder is taken and burnt. After burning the sulfur powder, this spatula is put inside the tumbler and the lid is closed. When sulfur burns, it takes up oxygen to form sulfur dioxide. Now, water is added in the tumbler and lid is again closed. When sulfur dioxide reacts with water, it forms sulfurous acid. Lid was closed tightly to ensure that no gas escaped from the tumbler. In the next figure, you can see that this liquid is tested on litmus paper. The blue litmus paper turns red and there is no reaction on red litmus paper. Sulfur reacts with oxygen in the presence of water. First of all, sulfur reacts with oxygen to form sulfur dioxide, which in turn reacts with H2O, that means water, to form sulfurous acid. So when we test this acid on blue litmus paper, it will turn red because it is an acid. Yes. So can you answer two questions? What will be the effect of sulfur dioxide on dry litmus paper? No reaction, either on red litmus paper or on blue litmus paper, because the litmus paper is dry. The second question is, what will be the reaction of sulfur dioxide on moist litmus paper? If it is blue, it will turn red, because what happens is sulfur dioxides react with H2O to form sulfurous acid, which turns blue litmus paper red. So far we have learned the reaction of metals and non-metals with oxygen to form their respective oxides. And we have also learned the nature of oxides. Like oxides of metals are basic in nature, while oxides of non-metals are generally acidic. To test the nature of the oxides are dissolved in water. When these oxides react with water to form hydroxides, they are called basic in nature, like metal oxides. While when these oxides react with water to form acids, they are called acidic in nature, like non-metallic oxides. The examples are sulfur dioxide and carbon dioxide. When carbon dioxide reacts with water, it forms carbonic acid. When sulfur dioxide reacts with water, it forms sulfurous acid. When magnesium oxide reacts with water, it forms the corresponding magnesium hydroxide, which is a base. So to test the acidic and basic nature of the oxides, we have to dissolve these oxides in water. When these oxides react with water, it shows their nature. Like sulfur dioxide doesn't show its nature on dry litmus paper, while when it reacts with water, it shows its acidic nature. Reactions of metals and non-metals with water. Now we will discuss the reaction of metals and non-metals with water. Sodium is very reactive metal. When it reacts with water, it forms hydroxide. The reaction is exothermic. A lot of heat is released in this reaction. Iron is a metal, but it reacts slowly with water. As I told you, sodium is very reactive. It reacts vigorously with water. The reaction is highly exothermic as a lot of heat is produced in this reaction. Let us see the reaction. Sodium in the solid state, it reacts with water, that means H2O. In the liquid state, to give out sodium hydroxide. In the aqueous state, sodium hydroxide is popularly known as caustic soda. The reaction also gives out hydrogen gas. Now the second reaction, it is with calcium. Again in the solid state, it reacts with water, in the liquid state, to give out calcium hydroxide, aqueous, and hydrogen gas is released. Now proceed towards the third metal, that is potassium, which is represented by K. It also reacts with water, in the liquid state again, to give out KOH. What is this? Yes, potassium hydroxide. In the aqueous state, it gives out hydrogen gas and a lot of heat is produced in this reaction, because potassium is also very reactive like sodium. Now during the third reaction, this one, the hydrogen gas generated catches fire and rapidly burns, because this is also a vigorous reaction like this one. In general, we can write as when metal reacts with water, we can represent as M, and this can be represented as H2O. It gives out metal hydroxide. Metal hydroxide plus hydrogen. This is a general reaction. Understood? Generally, non-metals do not react with water, but they may be very reactive in air. So they are stored in water, like phosphorus. Phosphorus is very reactive in air. It catches fire when it is exposed to air. So for caution, it is stored in water. Reactions of metals and non-metals with acid. You must be familiar with acids like HCl, hydrochloric acid, H2SO4, sulfuric acid. So now we will discuss the reaction of metals and non-metals with acids. Now we will do some experiments. Take a number of test tubes and add metals and non-metals according to the table given in your textbook. In different test tube, you will add metals, and in some test tubes you will add non-metals. Now take a dropper and add dilute hydrochloric acid in each of these test tubes. You will see some reactions are occurring. In some test tubes, no reaction will occur. Heat those test tubes. This was the first part. In the second part, again take the same metals and non-metals in different test tubes and add dilute sulfuric acid in each test tube, drop by drop, and record your observations. Now take a burning matchstick and keep it near the mouth of the test tubes. You will hear a pop sound in some of the test tubes. Now look at your observations and inference. Let us discuss. Metals react with acids to form salt and release hydrogen gas. When you bring a burning matchstick near the mouth of the test tube where metal is reacting with acid, you will hear the pop sound. This is because of the presence of hydrogen which burns with a pop sound. Except copper, metals react with hydrochloric acid slowly at room temperature and vigorously on heating. The first reaction is of magnesium, which reacts with HCl to form salt MgCl2, that means magnesium chloride, and hydrogen gas. The second reaction is of aluminium foil with hydrochloric acid dilute. It reacts with HCl to form AlCl3, that means aluminium chloride and hydrogen. When iron fillings in the third test tube react with HCl, that means hydrochloric acid, it forms the salt FeCl2, ferrous chloride or iron chloride. The reaction occurs vigorously on warming. Pieced flexible wire of copper does not react with hydrochloric acid even on heating. The reason is that Although copper is a metal, but it is placed below the hydrogen in the reactivity series, and for this reason it cannot displace hydrogen from hydrochloric acid. Thus the reaction does not occur. Now the reaction with sulfuric acid. The same materials are taken and sulfuric acid is added drop by drop. In the first test tube, you will see the reaction of magnesium and sulfuric acid, where the salt of magnesium is formed as MgSO4. That means magnesium sulfate. Hydrogen gas is released. The reaction occurs vigorously on warming. In the second test tube, aluminium is reacting with H2SO4 to form the salt aluminium sulfate and release hydrogen gas. In the third test tube, iron is reacting with sulfuric acid to form the salt ferrous sulfate and release hydrogen gas. Now copper. Copper reacts with sulfuric acid to form copper sulfate and hydrogen. The reaction occurs vigorously on warming the test tube. Charcoal and sulfur powder neither react with hydrochloric acid nor with sulfuric acid because both are non-metals. They do not show any reaction. The observation is recorded in this table. You will observe that copper does not react with hydrochloric acid even on heating, but it reacts with sulfuric acid. Reactions of metals with bases. When you bring a burning matchstick near the test tube where the acid and metals are reacting, you will hear a pop sound. You know, when acid reacts with metal, hydrogen gas is released. This hydrogen gas burns with a pop sound. The same happens when metal reacts with bases. Now, take few pieces of sodium hydroxide pellets and dissolve them in water to make a solution of NaOH, that means sodium hydroxide. Now put a piece of aluminium foil in it. After shaking the test tube, take a burning matchstick, bring it near the test tube. The same thing happens. You will hear a pop sound. What does it indicate? The same thing, presence of hydrogen gas. So aluminium is a metal, NaOH, sodium hydroxide is a base. When metal reacts with sodium hydroxide, sodium aluminate and hydrogen gas are formed. Due to the presence of hydrogen gas, you will hear the pop sound. The reaction between aluminium and sodium hydroxide is very rapid and exothermic, and a lot of heat is released. Apart from that, the hydrogen gas released is also very explosive. So the reaction of metals with base produces salt and hydrogen. Reactions of non-metals with bases. Now let us discuss the reactions of non-metals with bases. They are not covered in the course of 8th standard, but I will give you an introduction. The reaction of non-metals with bases is complex. Give an example. The reaction of fluorine F2 with NaOH gives out oxygen, NaF and water. Hydrogen is not released in the reaction of non-metals with bases. This way you can easily check which material is present, metal or non-metal. If you bring a burning matchstick near the test tube where the material is reacting with base, you will hear a pop sound. And if in case non-metal is present, it is reacting with the base, you will not hear the pop sound. Displacement reactions. Look at these. These are pens. These are positioned like red pen, then green pen, then this blue pen. Can you see the positions? Okay. Now I am shifting this red pen in the middle. Again shifting this blue pen in the middle. I am shifting the position of the pens, right? So one pen is displacing the other, right? You just watched a simple activity where I was changing the position of pens. This was a kind of displacement. I was doing it manually. Now let us do an experiment. Beaker A, beaker B, beaker C, D and E. In beaker A, copper sulfate, CuSO4 is reacting with zinc granules. Zinc. In beaker B, CuSO4, copper sulfate is reacting with iron, Fe. In beaker C, zinc sulfate, ZnSO4 is reacting with copper, Cu. In beaker D, iron sulfate or ferrous sulfate is reacting with copper, Cu. In beaker E, zinc sulfate, ZnSO4 is reacting with iron, Fe. Okay, so after reaction, we can see reaction is occurring in beaker A and beaker B, while no reaction is occurring in beaker C, D and E. Let us find out what is happening in beaker A and beaker B and why nothing is happening in these three beakers.
In beaker A, copper sulfate is reacting with zinc, Zn. Zinc replaces copper from copper sulfate solution to form zinc sulfate, ZnSO4, and copper is displaced. This copper is deposited at the bottom of the beaker at red powdery mass, while copper sulfate is a blue solution. You can easily recognize the change of color. This was the reaction in beaker A. Now let us see what is happening in beaker B. In beaker B, again copper sulfate is reacting with iron, Fe. Again, iron is more reactive than copper, so it displaces copper from copper sulfate solution to form ferrous sulfate. And copper is separated. Now ferrous sulfate is green. Again, you can recognize that reaction has occurred by the change of color, as copper sulfate is blue. Now let us discuss the observations.
There was no change in the beaker C, D and E. What is the reason? Science depends on facts or reason. Nothing happens without a reason. So in beaker C, D and E, you have recorded the observation that no reaction occurs. For knowing the reason, you have to study the reactivity series, where the elements are arranged in order of their reactivities. The most reactive metal is at the top and the least reactive metal is at the bottom. The reactive metal displaces the less reactive metal. Let me explain the observations. In the first beaker, zinc replaces copper, as zinc is more reactive than copper. In the second reaction, iron replaces copper because iron is more reactive than copper. In beaker C, copper could not replace zinc. In beaker D, copper could not replace iron. In beaker E, iron could not replace zinc because of the less reactivity of copper to zinc, because of the less reactivity of copper to iron, and because of the less reactivity of iron than zinc. Uses of metals and non-metals. Look at this and this. These are all metals. So now you can guess how useful metals are in our daily life. Now look at the uses of non-metals. We are breathing oxygen. Oxygen is a non-metal. Nitrogen is required for the growth of plants. Nitrogen is a non-metal. Have you seen the purple colored solution which is applied on wounds as an antiseptic? Do you know what is it? Yes, it is iodine, which is a non-metal. When water is impure, we use chlorine to purify water, and chlorine is again a non-metal. So non-metals are also very useful. Sulfur and phosphorus are used to manufacture crackers, which we fire on Diwali. So that was your lesson, materials, metals and non-metals. If you like the video, please hit the like button and stay tuned with us by subscribing our channel, and do not forget to hit the notification bell to receive updates of the upcoming videos. So that's all for today. We will meet with the next video. Till then, bye bye.